So satisfying.
Here we have office spaces. It's like 30 offices in that row over there. And then this is canteen, and up here we will have electronic assembly of inverters and things like that upstairs.
All right.
And then we have some hangout area over there with some video games and pool tables and things like that.
Wiring harnesses that were over there are now over here?
They're over here. We will just see them shortly. So it's a good opportunity space. It used to be a toy factory making toys.
Right. Okay.
And then
and now you make bigger toys.
Bigger toys, exactly. And it's right by the highway outside of Ängelholm. So we have our logistical center here, on the warehouse, and pre-assembly of Jesko chassis that goes onto the final production line in Valhall Park. So they get the ghost on the cars as well.
Perfect. Super cool. It's got a really nice feel about it. It's great.
Yeah.
And the coffee is excellent.
This first, there are four, like we call them, ships. So this is ship number one. So this will actually turn into our aftermarket division, which we have down in Valhall Park now. But that building we will change into battery manufacturing. And they needed more space for aftermarket. So this whole area here, up until about here, will be aftermarket. Then we will have electrical motor assembly over here. Right now we're just doing some low-end car builds here, but this will totally change in 2-3 months.
So is that a Jesko buck?
That's a Jesko buck. We can pre-fit the body panels, draw lines, check everything that it's perfect. So this is an air gate.
I need a garage door
to make sure we have the right temperature in this room. So I cannot open this door until you come in, until that goes down. So I have to wait a second.
Right.
So, and that opens. Hello. Here we have cork pieces.
Oh yeah, wow. So that's the size of a cork?
That's the size of that's half of a cork. The other half is over there, I think. Yeah.
But it's tiny.
It is tiny. It's 250 kilowatts. Yeah, so it's like 300 something horsepower. It's 600 Newton meters of torque.
Wow.
Yeah, and that's what sits on the crank of the TFG. Then we have a bigger version of this going on the rear motors, which we have yet to unveil. With a different
Wow, interesting.
So here's the CMM machine.
So beautiful, isn't it?
Clean room, and temperature is very well controlled. It's very even temperature and also moisture. So we have a nominal setting of all the components, because aluminium and steel, it expands and contracts with temperatures, and some components might be affected by humidity and so on. So it's a very controlled environment in here. We probably shouldn't.
Finite.
We probably shouldn't bring the coffee in here. We hide it. And then you have this very accurate probing machine on this granite table. Exactly. Super heavy with a special foundation, so you can check that the parts are according to the tolerance set in the drawings and in CAD.
So you've constructed this room specifically since you've acquired this place?
Yes, correct.
Wow. So satisfying.
So here we're just starting the pre-assembly of the Jeskos, the production Jeskos.
Wow, it's getting really real now. It's ramping up, huh?
Yeah.
Incredible.
This is the first station on the production line. Right now they just moved the bottom part of the monocoque over there, but this is the first monocoque bonding station. So here comes the parts in for the carbon monocoque. It's clamped in and bonded and cured and then taken over here, and the piece they just made here is this piece.
So you're actually forming the tub here?
Yes.
Wow.
It's becoming the tub here. You see all these kind of loose parts being bonded to the tub, becoming the tub, the top bottom part, getting the fuel tank in, and now we're going to get the windscreen framework, the roll bar, the side pods, and then you have a monocoque. So it's let's say a 3-day cycle per station. So it takes some hours for the epoxy bonding agent to cure, and you have this jig that holds everything in place nominally. And every third or fourth chassis now in the beginning, we scan each one of them with a laser scanner. But when we have this routinely, we only have to do it every third or fourth chassis to make sure nothing has moved or changed in the jig. The speed we're expecting from October onwards this year. Right now we're starting with a 10-day cycle. By summer we're going down to 6 to 5-day cycle, and the highest speed we will reach at the end of the year is a 3-day cycle.
Wow.
So it means theoretically we can get a car out every 3rd day.
Amazing.
Of this line. But then sometimes you have to wait for suppliers on parts, sometimes there's some bespoke features that makes it slower, but theoretically you can run a 3-day cycle.
Right.
So in reality, maybe if you get out a car sort of every week, then that's pretty good. And then of course you have vacation and holidays and this and that, so in reality it will be even a bit little less than a whole week.
Right.
But quite much faster than we've done it before.
Sure. These are the things you don't see, the channels for the wiring, huh?
Cooling channels. No, these are actually side crash pods out of carbon fiber and Dyneema. Dyneema is kind of it's again sort of a bulletproof vest material. It's similar to Kevlar, but next generation, even lighter and stronger than Kevlar. You make fishing lines out of them, and things like that. So we pioneered this on the Regera with Dyneema.
So it doubles as channeling for
it's holding
wiring,
the pipes, and then there's foam inside and carbon and Dyneema on the outside. So in the side pole test, we don't damage the monocoque.
Right. See. Okay.
So we're allowed to damage the monocoque. You're not allowed to damage the persons inside.
Yes.
So we kind of design it to avoid that happening.
Avoid that in the first place.
With this, and of course that increases the margin of safety even further. And then we're dressing up the monocoque with all the pipe work and evap canister, oil systems, hydraulic lines, engine mounts. You can start to see electronics coming inside here, control boxes, all the Koenigsegg stuff.
The connection points are fascinating. Look at those.
There you go again.
Yeah, incredible, huh?
And here you can see you're filling up this crash pod with all the pipes. Actually, the pipe work, of course, help also to absorb energy.
Right. Sure.
As a second by effect, but it's easy to replace if needed. Infotainment controller for over-the-air updates, the screens, the whole cockpit area, the cameras, the bird's eye view parking. Wow. And here you can see these parts are pre-polished, raw carbon fiber.
Yes.
They're not coated. When you open the hood, this is what you see in this finish.
I mean, when you see it exposed like this, you appreciate that it is part of the tub. You know, it's not aesthetic carbon. It's actually structural. Yeah.
If you want to do something crazy, you can stand up here.
You serious?
If you want to. So
I'm not going to get this opportunity again. So
most of the strength in a rollover is of course here. You're sitting underneath there. But for homologation, as it's a convertible, this doesn't even count. This is what they say you need to take the load. So the car passes with this as a rollover structure. This is just a bonus, which is much stronger than this. But even without the window in, and if you look at the weakest spot here, you can try to stand on it or hang on it or whatever you want to do.
All right.
And see what it feels like.
Okay, look. This will be a first. I want to make sure I don't. I'll probably just do that. He's not joking either. That's the real deal. Wow, that is. Yeah, you'd think it would flex, wouldn't you? It's just not even.
It's hardly budging.
It's zero.
Yeah.
I don't know how you do that.
Incredibly strong.
So that is your.
And you can see that, I mean, the shape doesn't lend itself to strength. It's like a trampoline going forward. Of course, when you put the window in glass, it becomes even stiffer. But that's this hollow structure. It's super strong in itself. And if you do have a rollover, of course, it's here and not here.
Yes.
So that's the absolute worst point for it, where you just put your weight on it.
Super cool. Well, didn't think I'd be doing that this afternoon. There we go.
And so this is actually a temporary gearbox going in. It's waiting for the real part.
Okay.
But it's becoming more and more assembled. This whole rear end is pre-assembled over there and docks back to the monocoque. And the whole front end is assembled over there, and then it docks to the front.
Can you tell at this stage if it's an absolute or an attack?
Well, yes.
It's got front suspension.
See here,
sorry, front triplex.
Triplex suspension.
Okay, exactly. So this is an attack version.
Yes.
Yeah.
Correct.
What size are the discs? They look substantial.
Yeah, they're 400 millimeters.
400 mil.
Or 402 maybe. So
right. It's cool seeing the linkage exposed.
Right. Yeah. So to robotize it, we replaced this gas strut with a hydraulic strut instead. So it's hardly any bigger than a gas spring.
Right.
But it's activated with hydraulics. The shock absorbers, we have active bump and rebound control that we developed in-house. And inside here you have a processor and a little computer that controls this, that we can over-the-air update through the cloud together with the rest.
So you update your suspension characteristics
you could.
over the air?
Absolutely, when we want to. Yeah.
So what's it like to drive? I mean, you spent time in the dev car, right?
It's shocking.
Is it? Yeah?
It's shocking.
Like terrifying and awesome at the same time.
Yeah.
Yeah.
Adrian Sutil, the former Formula 1 driver, he's a Koenigsegg fan, has a couple, and I took him out in it. He was like, what? Totally blown away. I can't express it in any other way than it just feels like a enormously powerful, huge go-kart. It just, wherever you throw it just goes there with no hesitation, it feels weightless and endless of power.
And the shift experience, it's
just the best I could ever imagine. Yeah, so you need to try it. You need to come back and have a go. Wiring harness.
Oh, wiring harness is here.
Discussed before.
This blows me away that you actually do this in-house. It's
you can see at this stage it's quite a few wires to consider.
It's complicated. Hi, how you doing?
Good, you?
Great, yeah, good. I was just asking, is that as crazy as it looks? Because it looks pretty intense.
It's okay.
Yeah?
Yeah.
It's okay?
A lot of wires.
Descriptions on which cable we have it in the computer. So
right.
we have the connector's name, and then we have the cable size and color of the cables.
We have a machine at the end of the process where we can connect all when it's done on the board, we roll up a machine and then we connect all the connectors to a counter wire harness into a computer, and then you press a button and it checks all the routings that each cable is on the right pin. Otherwise, it won't give you a green light, and it will tell you which wire is not in the right position.
So that's your sort of quality control stage?
Yes, and it's amazing how few times there's anything wrong, because there's, if you look statistically, so many pins here, so many pins there, it's like so many chances for one being in the wrong position. And of course it happens sometimes, but then that's
what that's for, right?
Yeah, exactly. So when it leaves here, we know it's right. But actually, if you zoom in on these wires as well, these are not normal automotive wires. They are actually aluminium inside, and a different type of cover that's thinner and stronger than normal automotive wires. So it saves about 20 kilos of weight in the car.
20
it's more like aerospace military grade wires.
That's awesome.
Yeah, it's
awesome.
Crazy.
It really is.
There are kilometers of wires in the car. So, So just going thinner and aluminium instead of copper. Again, you can see.
Oh yeah.
On the back side of the connector.
Okay, so that's the end result.
Yeah. So there you have the pins. And I mean, the cables are overlooked many times. It's the nervous system of the car, and for us, it's like a human being is built in one place with nervous system, cooling system, oiling, fueling system, and so on. And we just think it's such an integral part of the vehicle as a whole that we would like to really have control over it.
So at what stage did you decide it's the right time to bring it in-house?
I think it was about 10 years ago.
Oh, that early? Wow, okay. So it's not a new thing.
We didn't bring in everything, we brought it in step by step. Now we pretty much do everything here. So.
Right.
And this machine is very important. This is a laser etching machine, so each cable that goes in there, it's fed through here, laser etched with Koenigsegg and a number on each wire, telling what it is. So when you look through a wiring loom in the car, you can find it's every like 10 centimeters or something. You can see the number and the name, what it is and what it does, just by looking at the cable. And then it goes through here, and then it's cut and spliced, so you have the right length going into production over there.
You just look at it. It's stressful looking at it.
So if you need to fault find something, you have this bundle. What's what now? What? Yeah. And you can start reading on them. And okay, this one is damaged or something. Okay, it's for this. Here we have. No, these are still Rigidity lamps. Yeah, I guess we're doing Jesko lamps here now as well.
Yeah. These fans here, are these extraction or cooling?
It's circulation. So you have cooling fins here.
Okay.
And then you have circuit boards in here. So it's sucking in.
Okay.
Going under here and blowing out. So it's also a demisting.
Right.
Cooling and demisting. We actually use the glass as a cooling surface by circulating the air around the glass and demisting it.
So you have a sort of heat sink in the
it is, and it's connected
lamp
to the
itself.
circuit board. Exactly. Now this is quite interesting. These are some wishbones, and you can see the kind of the intricacy of them. But this is something we're very proud of, this bushing here, which gives extremely good handling and response of the chassis, but also compliance. So it's a needle bearing in this direction, so long needles. So it's super stiff mounted, but with very low friction. But then it's O-ring in this and that side, so you have a bit of a compliance in this direction. Okay, so it gives super high degree of comfort and let's say feedback and stiffness at the same time. Yeah, it doesn't weigh much.
Super light, huh?
Yeah, it's almost nothing.
Wow.
So that's actually the bottom part of the monocoque that goes into the first station, where you put the fuel tank inside. So we bond in the fuel tanks into the monocoques. Okay. I have been doing so for 25 years.
Really?
I mean, this is the Jesko tub. It's bigger, it's different, it's new carbon fiber, but the principle is the same.
Yes.
The fuel tank is molded into the chassis in that station. So it's cocooned, you can never get it out. You can have access to the fuel pump holes. You can get in there if you have to do something.
Yeah.
We pressure test it like 5 times before it goes in through the process transportation. Yeah. It's an rubberized aluminium tank for evaporation. Okay. And it doesn't really touch anything. It's kind of cocooned sitting on small rubber cushions, and it's never allowed to break.
Sure.
Theoretically, you can repair it somehow by getting in and maybe drilling a little hole or something.
If you need to.
But they have never ever leaked, ever. So
brilliant.
So they're in the most safe part of the car inside the monocoque instead of sitting freely outside. So it's proven to be very good solution over the years.
And so after Jesko, will you be using this space for future cars?
Yeah. So I mean, there will be a car after the Jesko. Right. So the idea is to keep this line running, and we have 2 final assembly lines in our existing facility, and then we have for the Gemera in the new factory. So whatever comes after the Jesko will go on here. Right. Eventually.
Sure.
So here's warehouse, vertical picking machine.
Wow.
So, and then...
Got all the tubs set up there.
Right, you can see the tubs there, exactly. This is the warehouse for the Gemera, but we are no need to fill it up just yet. Right. So we're starting to use the space for some development area before we have the new hangars in order. Right. So we have a little area here to assemble and test e-motors. So here you have some more parts of the core.
It is so compact, isn't
It's very, very compact.
Unbelievable.
So it's a carbon fiber ring around the rotor to hold the magnets that we manufacture in-house as well. Super stiff.
A carbon ring?
Yes.
How do you even go about making that? I mean,
it's to hold the magnets not flying away at 10,000 RPM. And then here we're setting up, we have another test rig in the other facility, but here we're doing a couple of these development rig tests for the e-motors and inverters. So it's a huge electrical motor, so it's basically an electric motor dyno.
So the torque you get off that is substantial.
Yes. You can heat up the building with it. And then over here we have the bonding jig for the Gemera chassis, the production bonding jig actually. So it's what you saw for the Jesko over there, but for the whole Gemera chassis.
So eventually this will form stage 1.
Exactly, in the new building.
Gemera tub.
So it's temporarily
in a new building, right?
Yeah. So we're bonding the first test chassis here, but this is actually the production unit. Wow. So you can see the sides of the Gemera there. Yeah. And it goes in and becomes the whole tub. You have a roof over there.
Look at the aperture's huge. It's brilliant.
Right. Yes.
B-pillarless car.
That's it.
Super cool.
It is actually a feature.
Big time.
It changes things.
It does, really does. I mean, just, ingress, egress, the whole thing is just easier, right?
Yeah. To me, it makes sense. And with a Koenigsegg door, you can actually park so close to another car. Sure. And both front and rear, without moving this, it just walks out. It is awesome. I mean, how many cars can you do that? If you have kind of a coupe with a rear seat, you have a long door and you have to swing it out. You hardly get out from the front seat and you fold the rear and you back out. It's just something completely different.
Yeah. Plus, also when you open it up, it's a real theatrical experience because it's the whole internal of the car on show. There's no post blocking it.
It was too tempting not to do it.
To do it. Yeah.
we had to, of course, I mean, the B-pillar on a normal car is very much part of the side safety structure, so on, and with the bigger hole, we had to, of course, do some special designs and reinforcement in this area with Dyneema and so on. And
Okay.
have the door with a big beam, carbon fiber
Through
beam,
it.
taking up a load through these two positions. So it required a usual amount of
Yes.
engineering to make it
Actually
even
achieve
safer than a B-pillar car with that kind of length.
You can only really achieve that with a full carbon
Yeah,
tub,
it will
can't
be.
you?
Of course, you can do it in steel or aluminum, but it will be very heavy.
Sure, yeah.
To make it lightweight, you need carbon.
Yeah.
To have all those safety features.
It's worth it, it's super cool.
So yeah, this is work in progress.
Brilliant.
This building, but it's space to grow.
It absolutely
So-
is, it's huge.
And yes, as I said, old toy factory, so I thought it was suitable.
It was appropriate, yeah. Roof section.
Yeah,
here.
roof section for the.
So this
for
is where the
Gemera.
glass sits.
Exactly. Yeah. So
Right.
this is the outer panel. And actually, this is interesting. You see how this doesn't look like normal carbon fiber, or
Yeah.
you don't see the weave like on the understructure here.
Uh-huh.
So this type of carbon fiber is easier and quicker to paint with color than that one if you
Right.
don't want any print through. It's
Sure.
still carbon fiber, but it has a finer weave up top, and then it
Yes,
has a
much
bit of a
finer.
filament baked into the carbon that you can
Okay.
sand away, and then you have a
Much
more
easier
smoother
service.
base than a big weave.
Right, I see.
So
That's cool.
for non-clear carbon cars, we're
Yes.
using this kind of panels.
Yeah.
And for clear carbon, we have the
Right.
other type.
I didn't realize it was a skin, as it were, you know.
Yeah, so it's
Yeah.
bonded together. We can lift this up. So that's the understructure there.
Right. So are these
Suppliers
parts effectively for...
These are mostly some, of course, Rigera spare parts,
Yeah,
some spare parts for some older cars, but mostly Jesko production parts.
right, okay.
Mostly. And you can see it's not fully filled up, and I don't think we'll fill up so much more for Jesko.
Right.
So we will fill up with Gemera, but Gemera running at the 1 car a day rate.
That's a different story, right?
We need
You're
that
going
as
to be
well.
in there.
Yeah. Yeah, so that's a little bit of an update.
Brilliant. Well, thank you for showing us around. The last few days, I mean, I feel really honoured to have the experience so early and see it all unfolding. So thanks very
Yeah,
much.
it's an exciting time for
Really
us.
exciting.
Everything is evolving
Yeah.
and changing almost on a weekly basis.
Have you had time to sit back and go, what the hell's going on yet?
Not really.
No, yeah.
Just keep on running.
Yeah, brilliant.
That's more what we do. So I think in a year, everything has kind of. We got the new factory. This is settled in. We have the warehouse up and running. We
Yes.
have the production of the inverters and motors, and then we will be almost close to 800 people
Wow, really?
according to plan. So
Thanks.